Can you hear that? What is that noise? Must mean it's the Cheeky Science Show Christmas special. Woo! Yeah, I'm dressed like an elf. Anyway, since it's almost Christmas, I thought I'd tell you why I envy Buddy the Elf. But is it healthy? So, I suspect if you're actually watching this video, you've probably seen the film Elf. And if you haven't, stop the video right now and go watch the film. It's so awesome. But anyway, Elf is a great film, no doubt about it. But Buddy, the main character in the film, not only is he artistically gifted, I mean, he drew the Mona Lisa on an Etch-a-Sketch, but he also seems to be able to depend on a minimal amount of sleep. When he was asked, "How did you sleep last night, Buddy?" he replied, "Great, I got a full 40 minutes. What? No wonder I'm envious of Buddy. He gets to spend only 2.8% of his day sleeping, whilst we spend about a third of the day sleeping. Think about the amount of trashy videos I could make in that time." But you know, what's to stop me sleeping 40 minutes each day? Why do we actually need more time to sleep than that? Why do we even sleep in the first place? So let's start with the basics. What actually is sleep? So sleep isn't the absence of wakefulness. It's an active state, it's regulated and it's metabolically distinct, and it's essential for our health and well-being. It is also evolutionarily conserved in a majority of organisms, ranging from worms through to humans. And so sleep can be split up into 4 different stages. We have non-REM sleep and REM sleep, with REM standing for rapid eye movement. So REM sleep is meant to occur normally during the second half of the night, and that is said to be when you have your dreams, whereas non-REM sleep can be split up further into 3 different stages, which are light, intermediate and deep sleep. And so REM and non-REM occurs throughout the night, and it seems to oscillate between the 2 different stages of sleep, and the extent and duration of these different phases fluctuates between different people and within an individual as well. So wakefulness and sleep are both highly regulated, such that they don't occur at the same time. So to actually initiate sleep, it requires the suppression of the activity in the arousal systems that keep you awake. And what is known is that this inhibition of wakefulness is achieved by neurons in the ventrolateral preoptic area, and these neurons remain active throughout the sleep period. So what actually triggers the activation of these neurons? Well, probably a whole bunch of different molecules, but one likely candidate is adenosine, since there are many adenosine receptors on these neurons, and adenosine accumulates throughout the day. And it should also not be surprising, therefore, that sleep is also circadianly regulated, and so in the evening you see an increase in melatonin secretion, which is often referred to as the sleep hormone. So why is sleep so important then? Why is this essential for health? Well, there is an entire book about why we sleep written by Matt Walker, which even Bill Gates recommends that you read. Actually, it's one of his Christmas recommendations. I haven't actually read it myself, but I have watched Matt Walker give several talks online. One of which was a recent TED talk that he gave, which I'll link up there for you. But I will share with you now a few key points, one being that short sleep predicts all-cause mortality. Quite the hard-hitting statement, so sorry buddy, but this wasn't the only terrifying statistic that Matt talks about in the TED talk. He also talks about the consequences of the daylight saving time changes. So this is when the clocks go forward in spring and back an hour in autumn. So what was seen in a US study was that in spring, when the clocks go forward and you lose an hour's sleep, there was an increase in around 20% of heart attacks the next day. But the reverse was seen in autumn. So when people gained an extra hour, there was around a 20% decrease in the rate of people having heart attacks the next day. Pretty shocking and terrifying statistics. And it's also the reasons why people are trying to prevent daylight saving time changes and just to keep it consistent throughout the year. And just another shocking statistic that I'll share with you is that in sleep-deprived individuals, so this is after one night with only 4 hours sleep, they saw a reduction in the natural killer cells activity. So these are your immune system response cells. And the decrease was 70%. That's not 17, that's 70. So even from these few statistics, we can evidently see how important sleep is. But the scary thing is that when we age, there generally seems to be a decline in sleep. In particular, there is less slow wave sleep in the NREM stage. I was going to further explain that that's the non-REM stage, but it is the non-REM stage. Anywho, this decline is accelerated in patients with Alzheimer's disease compared to age-matched controls. So Alzheimer's disease is the most common neurodegenerative disease, and I have a video about that which you can click on up there. And so as I was saying, sleep disturbance is one of the earliest observable symptoms of patients with Alzheimer's disease. And as I'll go on to explain, there now seems to be a bidirectional link between having poor sleep and Alzheimer's disease, but Alzheimer's disease and poor sleep. And this creates a vicious cycle whereby poor sleep increases the likelihood of Alzheimer's disease progression, but also the symptoms of people with Alzheimer's disease triggers poor sleep. And so it's just a perpetual cycle. And so the evidence for this is currently limiting in humans and elves, but there's been many studies that have been performed in rodents that does support this bidirectional link. But just before I tell you about that, the important fact to know is that Alzheimer's disease is characterised by the presence of amyloid beta plaques and intracellular neurofibrillary tau tangles. So one experiment performed in rodents was to experimentally increase the levels of amyloid beta, and what they saw an increase in the fragmentation of the non-REM sleep. Other experiments have looked at the converse, whereby they've disrupted NREM sleep and increased the wake time, and they see an escalation of amyloid beta plaque formation. But why is this happening? What is the cause of this bidirectional link? Now, the cause for this is not completely known, but one potential system that could be involved is the glymphatic system. Now, I would suspect that not many people have heard of the glymphatic system before, and I hadn't really known about it until I looked into this research. And so what the glymphatic system is the macroscopic waste clearance system of the central nervous system, which includes the brain and the spinal cord. And like how we like to keep our houses clean, the brain and spinal cord should also be clear and free of toxic and waste products that build up over time, including amyloid beta plaques. But the rate of this clearance of the glymphatic system appears to be much greater during sleep than wakefulness. In particular, the majority seems to occur during non-REM sleep, because this is at a stage where the glial cells, which are the non-neurons of the brain, they shrink, and this enables a greater flux of fluid to flow through and clear out all of that toxic junk within the cells. And so, just to make things worse, so far we kind of accumulated all of this disease and disruption to a lack of sleep. But what a lack of sleep also means is that you increase the time that you're awake, which means more time for metabolic distress. So actually, when we talk about deprivation of sleep, it has to include both the impacts of less sleep and the impact of extended wakefulness. So we can now put all of this information together to summarise our current understanding of the link between sleep and Alzheimer's disease. So we'll place amyloid beta plaques in the centre, since it is one of the characteristics of Alzheimer's disease. And from that study in the rodents, they saw that amyloid beta increase disrupts the non-REM phase of sleep. And so we also know that the non-REM phase of sleep is where you have an increase in the glymphatic clearance. And because it's a sleep phase, not a wake phase, there's less oxidative stress and less build-up of metabolic byproducts. So by inhibiting this with amyloid beta, you disrupt NREM sleep, and NREM sleep is needed to prevent the buildup of amyloid plaques. So you get inhibition of the inhibition. And so because amyloid beta plaques seems to prevent non-REM sleep, it also increases the time spent awake. And so during wakefulness, there is less clearance of the glymphatic system, there is an increase in the production of oxidative stress and metabolic byproducts, and this all in all contributes to the increase in the production of amyloid beta plaques. So this is a positive reinforcement loop. So, it's not looking very good really, is it? But that's not the end of the story, because sleep could be used as a biomarker. Now, two major goals in Alzheimer's disease research at the moment is to try and increase early detection and also to provide better methods of treatment of the disease. Sleep could be the solution to both of these. For example, one method could be to increase the production of non-REM sleep, which could be achieved by using transcranial direct current stimulation, but these are kind of early days for this kind of research. And in terms of early detection, you may be one of the few people already using apps on your phones and watches that actually track your sleeping. The accuracy isn't great yet, but with more people using them, the software will get better, and it could be a really useful way to track NREM sleep patterns. So instead of envying Buddy the elf, maybe I should be more concerned about him. But then again, Buddy is a human raised by elves, whereas we're all humans raised by humans. Maybe that's the missing difference. Maybe the elves eat something different. Is all that sugar? Who knows? But the ironic thing is that Will Ferrell actually had very bad sleep whilst filming Elf due to all the sugar that he had. So who knows where that goes. But anyway, for today, I'm going to un-elf myself, as sleep is a biological necessity. So Merry Christmas, and hope you have a good night's sleep, and don't stay up waiting for Santa. So yes, it would be very productive to have only 40 minutes sleep, but hopefully this video has told you why we do need sleep, and therefore why it may not be a healthy choice for you. So as always, have a good Christmas, and thanks for listening.